Hi everyone. Today we are going to present the smart parking system, which is a low-cost, scalable IoT solution for real-time parking monitoring. Basically, have been all there late for the class or for the meeting, or just driving in a circles, hunting for parking spot, which takes a lots of time to reach the class, and also losses of fuel, and it's incredibly frustrating. So today I am demonstrating my solution to the problem: a low-cost, scalable smart parking system, where we have built a 4-slot prototype that uses simple hardware to monitor the parking spots in real time. It knows if a spot is empty or occupied. It wirelessly sends that live status directly to a mobile app. This is the app that's already connected. Now, what's the problem and solution? Basically, the challenge is to find available parking in a busy areas, so not to waste time or fuel. Now we are going to showcase the hardware component that we have been used. Microcontroller, then sensors, then wireless module, then power distribution, then connection, which is a male to female wires. 16 male to female wires connected via breadboard, M2M and M2F wires. Now this is a system architecture which has been showcased here. The hub and spoke model with the Arduino UNO as the central processing unit. Here first, the brain of the operation is Arduino UNO, which is basically a central hub that processes all the data. Next we have the eyes of the system, the 4 infrared sensors. Each sensor is responsible for one parking spot. They work by sending out an infrared beam. If a car park over it, the beam reflects and the sensor detects it. Then the breadboard is just being used as a simple power strip to distribute the 5-volt and ground to all the components. So how does the code works? Basically, you can check. We have used as a state change detection. This means it's not spamming the app. It's a smart. It only sends an instant message when a change actually happens, when a car gets parked or car leaves. Second is uses the Arduino's internal clock to track the timing, and so it calculates how long it's been there, and also sends a full status update every 10 seconds, which have been happening right here. Now the most important demonstration part. Let's in action. We have been using a serial Bluetooth terminal app, and we have been live dashboard. Here we have been present. Here we can see a system is showing S1, S4 are parked, S1, S4 are parked, and S2 and S3 setup is empty. Here S1 and S4 are parked, S2 and S3 are empty. So means this matches by physical setup point to point. That's 1 and 4 are blocked and 2 and 3 are clear for parking. Now please watch the app. We have been going to unpark the car from slot 1. Unpark the car from slot 1. Here you can show that the system 1 has empty. That's no car is parked here. Now instantly we'll check first one. We got an event message: slot 1 empty. Slot 1 empty. And it tells us that it was parked for 31 seconds. It has been messaged here. There it is. We get the slot 3. We have been park the car. You can check in the system itself that system 3 is parked just 1 second before. Now the system is completely live, and I can move this car from slot 3. Move the car from slot 3, that is unblocking the S2, and park it in slot 2. Park it in slot 2. So here we can see that the system has been empty S1, S3 is empty, and S3 parking system is moved to S2. So what we have is fully functional. It's a 4-plot prototype that reliably tracks the parking status and the duration we also went through a lot, debugging the system generation. And system generation. So what are the challenges solution we faced while doing this problem? One is sensor power issue. It may be incorrect pinout assumed, then inverted logic. The sensor sends high when empty, low when blocked. The code logic flip to the match. So the pin conflicts here we have gone is pin 0 and 1, which has been reserved for the USB module that reassigns sensor to pins 2 to 3 to 6 and 4. What are the results and achievements? We got the 4 parking slot, which is successfully monitored with real-time accuracy. Then 100% objectives met. That's all project goals have been achieved and tested successfully. Then 10-second updates. It sends a report and to the mobile device continuously when parked, when it's coming empty, any parking system is getting empty or not, whether any system is parked or not. So here the future enhancement. Basically, we have gone through the custom mobile app that graphically shows graphical interface with MIT app. That Inventor showing red and green parking indicators. Future we can make the cloud integration by replacing Arduino with ESP32 module for Wi-Fi to store the data in a cloud database. And for scalability, we can expand it to 50 plus parking spots using Arduino Mega microcontroller. So I am Saurajyoti Bhattacharjee.